Good afternoon, ladies and gentlemen. Can you hear me okay? Fantastic. Welcome to this afternoon session, looking at open transport. Particularly, this summit is looking at open optical transport. I'm very pleased to be here. My name is Simon Sherrington. I'm a research director at Analysys Mason, and I will be your host for the next hour and a half. We have a really packed agenda with a lot of really great speakers. You can see their names up here, so I won't read them all in detail, but we have Anders from Telia, Kazuya from NTT, Kingston from PAL-C, Jean-Francois from Vodafone, Nigel from Ciena, Vittorio from Politecnico di Torino, Abjit from IP Infusion, Esther from Orange, Oscar from Telefonica, and Matthias from Nokia. Welcome to all of our speakers. It is only an hour and a half, so for the mathematically minded amongst you, you'll work out that it's less than 10 minutes per speaker. So I'm going to try and keep things moving on at a bit of a clip. Speakers will give you an opportunity to ask questions if they're urgent. But if we're running short of time, we will have to stop that. But they've all said they'll be available perhaps later on over a drink. Definitely if you're buying the drinks, to ask any further questions that you may have. We have a packed schedule. We're going to start with a keynote from Ciena. Then we're going to get an update on the MUST process and how that's all progressing. Sorry, I pressed my slide too quickly, but an update on the MUST process and how that's going. We'll have a talk looking at how open optical transport is impacting on optical networks. We'll get an update on GMPY and how that can be used as a planning tool and a tool for evaluating vendors. And finally, but not least, we'll have a panel session looking at the interesting area of IP over DWDM. So having preempted his slide by pressing the button too soon, I shall pass over to Nigel. If you could give him a warm welcome, please. Thank you.
So, hi, I'm Nigel Davis from Ciena. I'm going to be presenting driving disaggregation and interoperability to enhance business value. So what we pull apart, we need to bring back together. So we've disaggregated the network. We've got a pile of bits. We need to bring them back together again. That means integrating. There's a challenge in integrating always. We've got the network of packet and optical devices now broken into more pieces. We've got maybe coherent plugs to put in routers. We've got to bring those together. We've got optical devices from different vendors. We've got to bring those together. How do we deal with that? We've got control systems we need to also bring together. So critical thing there is open standards. So right down in the device, we've got CMIS, OIF CMIS. We've got the guys there, some of my colleagues working on an interface definition for the control of the plug right down at the plug. And going to the other end of the puzzle, we've got TAPI, Transport API, which is very dear to my heart, which I work very deeply in that particular activity. So I'm one of the editors and contributors and so on. And TAPI is enabling us to connect controllers, focusing on photonics and OTN and so on. And the critical things in those standards are consistency of representation of some things. So we're aiming to give one representation of a particular entity, a termination point, that everybody then uses. But it's not just the termination points. That sort of gives us the words in a vocabulary. We code in Yang, that's the letters. But we also need to make the thing more straightforward. We need to have the phrases. And what we get here is the patterns of the way that the network is actually put together and consistent representation of those. And that's where the reference implementation agreement comes in, the RIA. TR547, there's also a TR548, but the key focus here is 547. TR547 gives us a set of use cases and requirements. We'll talk about the source of those in a minute. And it also tells us how we should represent each particular thing in the network, particular assemblies of things. And that's crucial when it comes to integration. And we in Ciena have both a northbound, which we present the model, and also a southbound where we integrate other vendors. And we've had a number of challenges integrating because of some of the patterns are not followed. So it's much easier if the patterns are followed. It's critical we have that specification. And we find that is a fairly unique type of specification across the other standards. So broadening that across some of the IETF work and so on will be important. And we've basically got to that position from learnings in previous standard activities. I've been involved in this stuff for now over 20 years, he said miserably. Over 30 years, good Lord. Anyway, we gained experiences on the earlier interfaces. We've learned how to build flexibility into those interfaces and so on. So learning and growing from experience is critical in this, and we need to bring that experience to bear on other standards. The goal is automation of control, and over the long term we gradually build up the capabilities to automate control of the networks, and that's driven by operator needs, and that's crucial because obviously they're the people who actually need to get the network to run, and if us vendors do something that doesn't help, then that's not good. So driven by operator needs, which brings me on to the critical role that TIP, OOPT, and specifically MUST in this case, but also Mantra are playing in that, where we've got for the first time, I think, really, a set of operators have come together in what you could call a collaboration, where they collaborate and compete simultaneously. They pull together and they're working on providing the vendors with a set of requirements and use cases that are consistent. So when we find requests from one operator, we get a set of requests from another one, we understand them because they look the same. So that's an important aspect of this. The operators are driving standards work in a number of bodies, from my perspective, especially into TAPI in ONF, also work into IETF, and that drive's been very important to help us understand what's important. And you know, we have our own ideas what's important, we get a good steer as to what's really important to the operators. And that also brings in a certification exercise where the interfaces can be tested and proved to be consistent with the requirements, and then each of the operators that picks that work up knows that interface is indeed conformant. And that certification, Ciena, we received a bronze badge for our interface. We're going to carry on. Bronze is only sort of a first stage in the process, so we'll carry on with that and aim to get higher levels and so on. We received that this year. That's for the northbound on the controls for TAPI. And the key thing is to enable best-in-breed capability. The challenge is balancing variety that we need to have as we innovate, so we each have our own different ways of doing things, with uniformity that we need to have a consistent mode of operation. And that's a challenge we're tackling in TAPI as we gradually evolve that interface, enabling different vendors' innovation. But innovation, as it becomes bedded in, and as one innovation sort of takes over, it becomes infrastructure. As innovation becomes infrastructure, you want it to turn into one way of doing it. So if we're operating successfully with a set of vendors and operators, we'll find a way of normalizing those varied things. And we're doing that in TAPI. I've been working with other vendors, with Nokia, for example, for a long time, and we've got a level of trust here. We know we're trying to for the best of the industry, we need to collaborate in this way as we compete. One thing we do need to do is converge the standards so that the standards become more consistent. So ONF have got a set of models, IETF have got a set of similar models but not the same. So I'm starting to do some work myself to try and help that convergence. And balancing continuity and change. Clearly we need to advance things, add new capabilities, change the way we do particular things as the understanding evolves, but we can't just keep changing willy-nilly. Because clearly, so I mean, Arturo was pointing out to me earlier that we need to make our next release of TAPI backward compatible, which we are doing, but it's really, really important. So continuity there, but also adding new features and changing. So that continuity through change essentially is a challenge, but we've again had some experience in that area. And driving ongoing evolution, but driving evolution towards what? So this is where we haven't got so much of a collective view, I think, but moving forward, I've got thriving together in the clouds, obviously multi-cloud environments. In the network, we've got disaggregated virtualized networks forming, so we understand that sort of capability is critical. Components start to get broken off and then reassembled using the standard strategies. But obviously, also open disaggregated control fabric, so recognizing that the controllers are still relatively monolithic. We need to find a way of breaking them into the appropriate parts. And the critical thing here is understanding where the component boundaries should be. So initially, yeah, we've got big lumpy controllers, but in the long run, we need to be able to break out path computation things and break out other tools. The picture at the side there is showing a set of tools, routing, maybe some wavelengths, defrag, and so on, various tools, layer tools for examination and so And those tools could be from mixed vendors in a controller fabric. We don't need to get his vendor, I won't say any particular, his vendor XYZ's product, you have to have it all. You want some PC, you may find that maybe Ciena's PC is great for one particular set of problems, Cisco great for another set. Can I have both, please? Well, you either get one or the other. So we need to get to a point where we can get the mix. So that disaggregation is something we need to start focusing on and understanding how we can do this. And then, of course, taking a holistic view of the layers and environmental factors and so on and so forth. So the controller's actually assessing everything collectively together at scale without there being a load of controllers and all sorts of different assemblies. And the key to that is open, extensible standards at the interfaces and also an understanding of how those standards then enable components to interplay in the controller. That allows innovative techniques. I put AI on here, but of course everybody knows that AI gets shoved forward as the answer to everything, and then it isn't. Clearly, it's got to be used in the right way. Machine learning, again, in the right way. Genetic algorithms the right way. Some things bend better to algorithmic solutions, other things better to some AI on big data and so on. It's choosing the right pieces. But if we get the structure of the controller right, it enables those innovations. And then you can start looking at best-in-breed assemblies in the controller too. So best-in-breed assemblies in the network, that's clearly what we're aiming for, to get the right plugs and the right routers and so on for the particular application, and not say I've got router X and I've got to therefore have this optics and it doesn't do my job properly. Same with the controller. Get the best-in-breed assembly. So put together the right pieces in an assembly of control components to actually solve the entire problem. And that is aiming to achieve ongoing enhanced business value. The critical thing is business value. There's no point in doing it otherwise. Break the stuff up and it doesn't give any value, purposeless. So we break it up at the points where it gives value and collective value via balanced standards. The standards, we're not standardizing everything, we're enabling innovation and so on. So it's a balance of the standardization that tames complexity, so removes unnecessary variety whilst enabling positive variety of innovation. And that enables solutions of best-in-breed innovative capabilities. And that's really what we're doing all this for. As I said, the key thing here is, I suppose one critical point is, though, that the operators coming together in Must and Mantra is particularly helpful to go and control that problem. And I think it's the first time we've seen that. So, thank you. That's my presentation. Do I have I've got minus 13 seconds, but any questions, anybody? And if not, you can always grab me afterwards and I can happily talk on tapping for several months, probably. Okay, thank you.
Fantastic. Thank you, Nigel. So next up to the stage, I'd like to welcome Anders and Oscar, who are going to give us a talk through the state of Must governance. Please welcome them to the stage.
Okay, thank you very much. Now we are going to talk briefly about Must. Okay, so I still remember a few years ago when a few operators joined together and said, hey, the SDN industry looks fragmented. We have so many different interfaces, so many different architectures, and we sat together and said, hey, we created the Open SDN Transport White Paper, and we proposed a unified way for the industry. And then some years later, we have a big bunch of operators. We have now, I think it's 9 operators that we have now, and we have managed to agree on a unified way. So what is the value that we are giving to the community? So with this, we have been able to tell the suppliers, okay, which is the SDN roadmap that needs to be followed in their product. So with that guidance, it has helped to develop their solutions there. And also now, we are beyond that, even beyond that phase of being able to have the definition. We are in the phase of being able to have a common methodology for testing the different products and the different and the solutions that we are proposing, how they fit in their products as they are today. So we are completing the gap. So you have seen we started a few years back with these unified architectures. We work in the requirements, and now we are doing the testing. So let's see how we worked in Must. So after doing this initial definition of the architecture a few years back, we created several work streams per technology. So we have one stream dedicated to the optical technology, and there what we have done is, after creating a couple of years back the use cases that we wanted to see in our operation, we moved to creating the first definition of the technical requirement, then went into the technical, detailed technical requirements, and now we have reached the maturity point where we gave or we awarded bronze badges to those solutions that complied with our requirements, and now we are starting the last phase, going for the silver badges. We are going to start testing in the labs or in the solutions and validate the solutions that are compliant with the requirements. In the IP, and there, as you can see in the optical work stream, we have like three main parts. The open terminals one, where we specify the interface of these open terminal devices. This is the one that is in the more advanced stage. And also we are reaching the technical validation phase in our optical SDN controllers, both northbound and southbound. That, of course, once we have all our open terminals ready to go, we will go for the optical controllers. In the IP work stream, the work that has been done after creating the set of use cases is doing the technical requirement document. This technical requirement document was distributed to the industry, and we created these detailed technical requirement documents, and now we are in the IP router side in the phase of doing the technical evaluation and starting to give also the bronze badges to those solutions that comply with the requirements. So it's a little bit a step behind, and then, as in the optical, once we have the routers, we will come next with the IP SDN controllers. And for the wireless backhaul, the work that has been done is sitting together all the operators, defining the common use cases, and producing, and it's publicly available, a first version of the technical requirements document. So this document is out there, is to be able to publicly available, so it's ready to collect inputs from the community. And lastly, so you can see which is the level of maturity that we have reached. In the open terminals, we have collected more than 10 responses of the requirements. So it's a huge one. Okay? And there we've been able to award bronze badges to both open terminals and to optical controllers. And now in the open terminals, we are now in this process of providing the silver badges. Okay, so just you see that now this strategy that we have been following for several years, now we are close. I hope that in the next year maybe we are offering the gold ones, but I don't know. Maybe next year we are in that phase. But you see, this is step by step. In the IP routers, also we have even the complexity. We have a good engagement of the community with 5 responses from the industry. And now we are working also in this process of achieving the same level of maturity, and hopefully we will see later on. We have some small slot to talk about the IP work stream. So I hope that soon we will be able to give also badges. So now we can go into more detail with the optical work stream.
Take it from here. I'm not sitting there. Thanks, Oscar. So maybe if you move. Let's go ahead and see where we are with the MAST Open optical transport solution. This is kind of a background on what we're doing and why we're doing it. We have 2 solutions that we are focusing on. We have the solution 1 with a single domain partially disaggregated network controller, which is a optical OLS domain controller connected via proprietary APIs to a ROADM system from the same supplier. Then we have via an OpenConfig interface a connection from the controller to the open terminals. Then we also have a northbound TAPI connected to a hierarchical controller. The solution 2 consists of a single domain partially disaggregated network dual OLS optical SDN controller solution, which contains of an optical SDN controller on the top connected to an OLS domain controller via a northbound TAPI interface. We have the OpenConfig interface connected to the OOTs as in the solution 1. And then we also have the MUST MBI TAPI connected northbound. We have 2 different type of evaluations that we are going through. As Oscar pointed out, we have done the evaluations of the bronze badges, and there are a number of badges received, as you could see in the former slides. And that is kind of the theoretical evaluation where we give it out. But then we also have, as Oscar mentioned, started the actual test procedure of doing the product test, which will, in the end, we hope mean that the solutions will receive the silver badges. Finally, we have the solution evaluation, where we have a common integration test of the full solution, which will end up in a gold badge receivement to the different products. And the prerequisite is, of course, that the different products that are part of this have received a silver badge from the beginning. So we have done quite a lot during the recent months. We have a collaborative effort between the PSE and MUST working groups, where we are augmenting the standard data models to GMPY requirements to unlock a multi-vendor optical network planning and physical impairment solution. We have also had an OpenConfig terminal device manifest that we have been working on in the MUST working group, together with the main optical suppliers. And that has resulted then that we have made an input to OpenConfig, which is on the verge of being disclosed now. Similarly, we have had contributions made for ONF TAPI, which will be available in Transport API release 2.4.1, which is available now, and also in TAPI version 2.5, which is coming soon, covering also the amplifier's physical characteristics through profiles. Finally, we have the IETF POI pluggable draft, which is considering the Mantra IP over DWDM architectures that we have been working on as part of their definitions, and you can see that, find that in the link below there. We have the following roadmap for the definition and modeling. We have planned for the MBI to have a technical recommendation document ready this year during Q4, before end of 23. Then we are going to work on the MBI test plan. That is our first priority during 24. So we can start to do the silver badge testing later on. For the SPI of the optical SDN controller, we are going similarly start to work on a SPI test plan version 1.0 to start to have a test plan, and so we can start to do the silver badge testing on that as well. Then we have for the optical terminals, as I mentioned earlier, we have the OpenConfig terminal device properties publication that is coming this year. And next year, we will be focusing also on updating both for the OOT and the SDN controller SPI, the technical requirements document, since both are considering the OpenConfig. Finally, we have in our plans, let's see if we manage to do it, a gold badge end-to-end solution project plan that we want to start to work on. But it also depends kind of how many silver badges we can award. Without the silver badges, no gold badge test. Finally, we have other development areas also that we will start to work on. We will try to work in parallel in the group in order to make this rather extensive plan happen. We want to work with the test automation project plan, and we are in the middle of doing use case evaluation amongst the operators so we can prioritize use cases for the EMPY, for the optical planning tool. I know that many of you in this room has been waiting for this. Here it comes. We are talking about the NBI evolution. First of all, we are looking into the maturity, and that is that the test that we are going to do is still going to be done based upon the technical requirements for TAPI version 2.1.3. That's the target release for us. In the evolution, here it comes. It's 2.5.0 we are going for in the next release. But we are going to focus also on prioritized features from 2.4.1. It's very important for us to have backward compatibility between 2.5.0 and 2.4.1. So 2.5.0 needs to have backward compatibility towards 2.4.1. That's something that we are prioritizing very high. Finally, what this means for us as well is that we will have to maintain both releases during a time, and we haven't set the date for it yet. But it will be that we need to have a release 1 and a release 2 that we are maintaining at the same time. This means that we will have 2.1.3 and 2.5.0 ongoing at the same time, which also means that we ask all the participants that are sending in answers to us to answer, if you like, of course, for both 2.1.3 and 2.5.0. And we will maintain both and test both in the end. And here we have a summary of the use cases and the features that we saw for our prioritizing. For the 2.5.0-2.4.1 that we are going to work on. We will dig into deeper with this when we are producing the new TRD for this, but this is what we have for the moment based upon the information and input we got by this summer from the ONF TAPI. So, what are we doing now for test and validation? I just want to remind everyone that we are awaiting DTRD response with the submissions deadline for November 20th. This is the next window when it's closing. We also then thereafter will start to evaluate it and hoping to finalize the evaluation by Midsummer's Eve. Arturo will throw a party when we are fine with it. And then in the beginning of 24, we will hopefully award a number of bronze badges after that. Then we are also doing the existing tests about the silver badges, and I will move on to the final slide for that. We have been doing the silver badge testing in Orange and Telefónica's labs, where we have tested NEC and Infinera bronze badge awarded solutions. We have done plus 150 test cases, which has been covering the inventory and service discovery, client and line interface provisioning, optical transceiver capabilities validation, optical performance monitoring, alarm and fault management, and finally streaming telemetry as well. Test reports are provided. We are discussing and going through with them together with the vendors. And when that is finalized, the MUST Optical Working Group will start to go through this. and we will see what we have as a result for this, and hopefully during, let's say, November, December, we will have a feedback if we are going to award silver badges. So then I hand over to Oscar again.
Thank you. So what have we done, and how are we going to progress in IP? So in IP, at the beginning of the year, we produced our detailed technical requirement document that we distributed to the industry, and we started to analyze the answers that were provided by the industry. We noticed that the scope that we were proposing was wide and complex. So this is why we are in the strategy that we are following now, is that we want to have a gradual approach. So this is why we are going to release a new version of the detailed technical requirements document, in which the future bundles are going to be split into some basic requirements and some advanced requirements. So this way we can achieve a gradual solution. Also, based on the feedback that we received, we are going to split the functionalities per device type that they are oriented. So in OPT, you know that we have several types of disaggregated disaggregated open routers. So we are going to start, for example, with the DCSG features. Okay, so we don't need the full rich set of IP capabilities, which is extremely complex. So this way, I think we can start going and start implementing solutions based on a standard interface, also in the router side. Okay, so with this, we hope that and we encourage our all our suppliers that are participating in the IP to collaborate with us in this new this new evaluation of the revised specification of the detailed technical requirement documents. And finally, some messages about all our work in MAST. We have seen that in the optical work stream, the strategy has been widely adopted by the industry. We have seen that it is the specification that we released was, let's say, good enough to serve as a base, and even now we are ready for the silver badges. So I think we are, in the optical, we are really good. So in the IP, I expect that we are able to catch up the optical work stream with this new progressive approach. We will have this new version of the detailed technical requirement documents, and we hope to get to continue with the engagement of the industry and even go further. And also, as mentioned, with this strategy of aligning the requirement document with the different versions of the disaggregated routers, we can align the requirements that we are needed with the requirements of OpenConfig, so we don't ask for more. And here we have what we've observed is that all the different operators in MAST, we are very aligned in the architecture, we are aligning the requirements, and this has proven to be ultra positive. And finally, just to remind that in MAST, we are not creating standards. Okay? We are using standards. Whenever we find that the standard is not good enough, okay, just we go to the standard, contributing the standard the way that the standard is accepting contributions, or we collaborate with other industry partners to fill that gaps, okay? But the goal here, remind, is not to produce standards, but always use standards. And you have seen at the very beginning that we started a few years back, we were starting 5 operators, now we are 9 operators. We encourage other service providers also to join here. In the OPT community, we have colleagues from all over the world, so I expect that we can even increase the community of service providers in our group. Also, I am very happy about the collaboration we have received from our suppliers, so I expect to continue this work and also keep the engagement even now more that we are going to the silver awarding phase, and just be patient, okay? So not all the products are tested now. Some of them are tested now. When the routers and the open terminals are mature enough, we will go for the controllers, okay? So just keep engaged with us, okay? So I encourage you to join us, and those of you that or have been, let's say, just a little bit less active, come. Okay, you see that the good success that we have with many suppliers, so come also with us. And with this, thank you for this part, and I hand over to you. And that's the black screen.
Thank you, Anders and Oscar. It's clear we're making a lot of progress. Next, I'd like to welcome to the stage Kingston and Cayuza to talk to us about some of the implications of OIS on optical transport. Please welcome them to the stage.
Thanks, Simon. Yeah. So basically, I'm going to talk about the impact of the open networking operating system on the packet optical side. Just a quick recap and introduction about the Goldstone or the packet optical NOS. This subgroup is basically the only subgroup in the OOPT which talks about or which is working on the software development side. And so what we are doing as part of this subgroup is we are developing the network operating system predominantly for some of the programs and the projects which is running inside the packet optical group actually. So as part of that actually we have developed this NOS which is called the Goldstone NOS, which we call it as. And just to provide a high level placement of the NOS, basically you have the different open routers with DCSG, DDBR and the DAR. And then you have the simulation systems and the DOS systems. And basically the NOS predominantly targeted for the disaggregated open routers. Currently, we are supporting, the Goldstone NOS is supporting some of these boxes. So the Cassini, Phoenix, and with Wistron FlexT and the DCSGs as well as the OpenBNG. So the EdgeCore AGR 400 is under development, right? So to give a little bit overview about the architecture of the NOS, basically it's purely a containerized based, and thanks to the SONiC architecture. And so basically, predominantly the Goldstone NOS is made for some of the programs which is running in the OOPT. So high level overview of the architecture. So it consists of predominantly 4 or 5 layers, I would say 5 layers. And the top 3 layers talks about the management plane, and the bottom layer is predominantly talking about the abstraction as well as the ASIC management layer, basically programming the ASIC layer, right? So the middle you have the sysrepo, basically the configuration database is stored in sysrepo based system, and you have the different northbound API interfaces which supports CLI, NetConf, GNMA and SNMP. And you have the southbound layer which goes and basically provides abstraction towards the control plane infrastructure. So we support multiple control plane right now, starting from the TIE to the microsonic and the TIE gearbox to microsonic to the TIE, and some commercial grade deployments as well, right? And so we also have a translation layer, because one of the important requirement coming is basically what kind of data models, the YANG models we need to support. So we have the translation layer which provides translation between the open config as well as the vendor specific things. Yeah. So these are all some of the trials and the deployments which is going on in 2020 to 2023. So predominantly, if you see from the OOPT side, we see deployment from Cassini as well as basically from the Phoenix side. So most of the deployments, what you see here is either coming from Edgecore Cassini or the Phoenix platforms. And just to name, the Multinet is one of the important deployment which is happening with Cassini. And the other deployment, probably Anna Savasan can provide more detail about from the entity side. So this is the high-level roadmap from the NAS subgroup. So you can split into two parts. One is from the control plane development side, and another is from the adoption of the new platforms. And basically, from the control plane side, typically, if you see, the Goldstone architecture came from Sonic. So what we have done was we took the Sonic operating system and we removed the non-relevant features for the packet optical side. Like the basic L2, L3 features, we removed it, and we have something called Microsonic. And on top of the Microsonic, all the other layers has been built. Okay. So what we normally do was we normally do an upgrade whenever there is a new release coming from the Sonic, which we adopt to the Microsonic. So that's one of the important ongoing activity which goes on the roadmap. And apart from that, other layer 3 features also is there in the roadmap. Actually, we were supporting some of the layer 3 features, but the latest migration to the Sonic has some challenges. So we are taking it for the next level of layer 3 features for the Goldstone, right? From the platform side, these are all some of the important development which we are planning. So some key thing was basically the support for OpenZR+, and then some open configurated support for the IP over DWDM. So just to give a little bit overview about the Cassini platform and what PALSI is offering as part of the Cassini platform, in general about the packet optical side, right? Just a little bit give an overview about PALSI. So PALSI Networks is a software services solution integrator company, and we predominantly working on the open disaggregated side. And if you wanted to explain or talk about PALSI, we name it as a integrator or aggregator in the disaggregated market segment, right? So this is one of the talk which I was talking in the last fews, because it's really important for the disaggregated network ecosystem to have some specialized aggregators who basically connect all the dots in the ecosystem. That's where actually PALSI is trying to do. Okay. So quick overview about the Cassini. So basically, this is one of the industry's first, I would say that packet optical, open packet optical transponder came actually. And it is a pluggable module, so it supports the CFP2 DCO modules, which is pluggable, so you can just go for a pay-as-you-go model. And it is flexible, and it provides basically the programmable interfaces. Predominantly, it is again coming from the software side, and it has gone through multiple interoperable testing with multiple the transceivers as well as the DCO modules. Okay. And so what PALSI is trying to do here, so basically we have adapted the Goldstone, and we just basically taken the Goldstone, the open operating system, and we just basically modified to run it into the Cassini platform. And we are planning for a silver badging right now, and a few parks and trials are going on right now. And as I told, basically we are trying to create an ecosystem for supporting some of these disaggregated networking deployments all across the world, predominantly on the India, because we see a lot of traction of some of these disaggregated deployment. So PALSI is working very closely with Edgecore in terms of providing disaggregated networking support inside India, as one of that program is basically coming from the Cassini. And so what is the status right now? So basically the Goldstone Cassini, as of now, we are supporting 5 different the CFP2 DCO modules. And PALSI is providing a 24/7 premium support right now for some of these deployments inside India. And we have a live demonstration of the complete the solution what we have spoken, right? It's there in the booth 42. And I would say that we are close to the deployment right now. Yeah.
Okay, so from this slide, I would like to explain about the DOS and Phoenix and its related activities in NTT. So this slide shows our work on ecosystem for optical transport. So, so far we have developed the hardware ecosystem and its network OS, the Goldstone NOS, with various vendors. The left-hand side shows the Phoenix, which is a white box type transponder, and it is commercialized by NEC. And also it received the silver badge from TIP. And then the trials are conducted by several operators like NTT Communications and MTN. And also, for the next Phoenix project, our new partners from HCore, Adtran, and Pegatron will join us. On the other hand, the right-hand side shows the switch ponder type white box suite, the white box. So not only supporting the max ponder type white box, we also would like to support the switch ponder type white box switch. So yeah, IP Infusion team is mainly contributing to this project, and we would like to validate the IP over WDM with coherent QSFP-DD. So I'd like to explain about these two topics. So first, this slide shows Phoenix and Goldstone validation. So as I said, NEC adopted and commercialized the Phoenix with NEC NOS based on the Goldstone NOS as a reference. And then several operators like NTT Communications and MTN are testing their validity, and the product has received the silver badge from TIP. So this slide briefly introduces the NEC Phoenix Solution TIP certification by NTT Communications and MTN. So they have tested and validated NEC Phoenix product compliance with TIP Phoenix test plan, and they validated more than 160 items under various line system configurations and various transmission quality. And then all of this test plan has been fully executed, and NEC solution has been proved to be compliant with the TIP DOS group defined evaluation criteria for Phoenix. So this slide introduces the ION Global Forum activities at Cosmos Testbed. So Cosmos Testbed is a large academic network constructed in US. So we are now conducting the experiments of automatic optical path provisioning and remote transponder, which are considered as important use cases in ION, a concept led by NTT. And NTT and NEC, who are our IZF members, are conducting this experiment with Porto University, Dublin University, Duke University, and Columbia Universities. So as you can see, there are so many artifacts from TIP. For example, the ZNPY and OPTTAI and Phoenix with its Goldstone NOS. So we have successfully validated the automatic optical path provisioning POC. And last week, ECOC had held in the Scotland, Glasgow, and we have received the best paper award with highest score, thanks to the artifacts from TIP. So finally, I'd like to explain about our recent activities. So we are now considering how to support switch ponder type platform of aggregation router AZ400 from HCore. Also, we'd like to try to support other platforms from UFSpace or CSR type platforms. So as Kingston said, the Goldstone is architected as a container-based and modularized network OS. So for the controlling switch control part, IP Infusion's Oknos is used on the Goldstone NOS because Oknos has shows very high performance for controlling the switch ASIC part. So we are collaborating with IP Infusion team, and also we are also utilizing the transceiver D from Sonic community. The containerized transceiver D is developed by NEC and NTT, and this module is introduced on the Goldstone NOS to control the OpenZR Plus QSFP-DD modules. So we would like to continue to collaborate with partners like IP Infusion, NEC, and try to work together with other communities like Sonic, and I'd like to expand our activities. Yeah, that's all for my presentation. Thank you.
Thank you, Kezia. Thank you, Kingston. Okay, so we're going to move from open operating systems onto the topic of GNPY, and I would like to invite to the stage Esther and Vittorio.
Okay, thank you. We talk about GNPY. This is this project on the abstraction of the physical layer. I start to depict the evolution, and then Esther will go in more detail on the specific application. But I'm a kind of alien guy in this community, as I'm a professor from a university, but I so enjoy to work with this community since 2017 and talk about the evolution, the journey of GNPY from a pure planning tool that we're moving toward an open digital model within an open digital twin to control networks. So this slide depicts the evolution. We started in 2007 with a pure planning tool, multi-vendor, vendor-agnostic planning tool, including auto-design features, and we start with simple transmission model and very good validation that were already really encouraging at the time. Then we prosecuted toward the extension of the model of the accuracy and speed up of the code, and we have done many further validation. And then let's go to the future that already started in 2023, this year, where we are moving toward keeping GNPY as a vendor-agnostic planning tool, but also towards GNPY being a digital model within a vendor-neutral digital twin. That means GNPY as a service for network automation. To this purpose, of course, the firm need is for open interfaces, and of course, we take advantage of the synergistic exploitation of artificial intelligence, machine learning in general, in order to increase the accuracy and to get more data from the field. Let's move quickly onto these slides that are showing the extremely encouraging testing that we have done. And on the left, you can read the pillars of GNPY. So we model transparent light path at Gaussian noise channels. And so it means that a unique parameter can define the quality of transmission for the propagation of transparent light path. And we can compare to the transceiver model obtained from back-to-back characterization and get great accuracy on this approach. So on the picture on the right, you can see two excellent validations that we have done together with Microsoft. One is in the lab in Seattle, where we tested different modulation format, different distances, full spectral load on the C-band, and you can see the accuracy. With Microsoft also, we have done, thanks to Microsoft, a test on a brownfield, on a portion of the core network on the US, and also here we got excellent accuracy. Then moving on with the further validation that we have done, thanks to the Orange, at the Orange Lab in Lannion, we have tested the accuracy of the model in flash grid, flash rate, multi-vendor scenario, including polarization, shaped constellation. And also with Orange Lab, we tested Nyquist carrier flexible transceiver up to 800 G. Also in this case, the accuracy of the model was proved to be excellent. Then on the corner on the right, we show the test that we have done together with NTT Labs on short reach on the scenario or intra-data center scenario. Also in this case, for short reach, the accuracy obtained by the model was excellent. And then it's not showed here, but it's worth to mention a work done with Internexa, operator from Colombia, that has been posted recently on a post of OPT that blog of OPT that you can read the use of GMPY in the context in really challenging scenario with really long reach, RAM amplification, remote pumping, and so on. So let's move on where we are in the modeling and where we are going. Is the scientific core complete? Yes, it's almost complete, but we are moving on to have a full picture of what is needed. Multi-band scenario and code speed up is already almost ready. We need final check test. As operator interested in testing C+L will be really welcome to share data. Latency estimation is ready because latency in fiber is indeed important. Advanced amplifier model we are developing during this year. ROADM model including PDL, filtering penalty across torque. We are doing this together with advanced transceiver. Of course, we have to work on open interfaces, Jan, TAPI, but of course, previously in the previous talk and Esther, we talk about this. And on the network of server that together with the digital model will build a digital twin. And finally, we are targeting an adaptive gain and tilt optimizer that will be enabled to set the working point of amplifier and also to include in the GMPY context machine learning and in general artificial intelligence model. So let's see where we can use GMPY within a context of controlling an open and disaggregated network. This is a generic open optical network where you have a controller, and you can see GMPY is there on the right side that together with the network of server build a digital twin that the controller can rely on to implement the operation that are specifically setting the working point of the amplifier within the optical light controller, performing the path computation to understand what is a feasible modulation format, bitrate, spectral occupation for a certain transceiver that can go from end to end, crossing multiple vendor line system. And of course, we need to develop open interface to enable such an operation. So, going to details on the two key operations, the first one is the path computation. The path computation is already feasible. So, we have a network, a transparent network. We define a source and destination SSD there, taking the description of the topology. We can feed GMPY with the description of the transparent light path. GMPY gives back the GSNR from source to destination. Thanks to the variability of the transceiver model, we can understand what is the deployable modulation format. Is it reliable? Yes, we have extensively proved the accuracy of the model, but there are some fundamental missing points. Of course, the topology availability, open interfaces and models, and open transceiver models that are just not scientific issues, but let me call political issues that have to be solved within the agency that are working towards standardization. Then move on the use of GMPY as a service within the optical light controller. This is kind of simple scenario where you have your line, you want to set the amplifier within the optical light controller, so you feed GMPY with the description of the line, with the model of amplifiers. GMPY can work within an optimization engine and give back the working point of each amplifier. Is worth to specify that this kind of operation can be an adaptive operation, can follow modification on the line, for instance, a fiber cut modifying a loss, a soft failure of amplifier that is not anymore able to give the maximum gain, all you can have in mind in order to set automatically the gain and tilt of each amplifier. So let's feel the last point that I listed at the beginning of this short presentation is, may artificial intelligence assist GMPY? Yes, of course, artificial intelligence may assist everything in our modern world, but which are the specific topics that can feed artificial intelligence by helping GMPY? So, if you look at GMPY, if you feed very well with accurate parameters GMPY, you get an excellent prediction with really limited inaccuracy. But if you if you go to the real world, you know that in real world you don't know in the exact parameters to fit to GMPY. So artificial intelligence can contribute to what I like to call physical layer tomography, that is to understand what is the actual fiber that you have in the field, what is the loss that you have, filter effect, and all the uncertainty that may come into your mind. And so by utilizing extensive data from the telemetry that are available in the modern network. Moreover, machine learning model can be effectively used to integrate deterministic analytical model for the propagation. And the first network element that comes to my mind is the amplifier. The amplifier is a strange guy that is not behaving exactly as expected. So if you are able to feed to train machine learning model, you can get great accuracy also in predicting the behavior of an amplifier also with different spectral load. And then the last 2 points, thanks to the artificial intelligence, data from monitors can be compared with GMPY prediction. So you can get the nominal and the actual behavior of your network, and so you can enhance the potential for failure prevention or also for other issues like environmental surveillance can be implemented in optical network. Last point is about the artificial intelligence that can assist the creation of a self-healing network. So you can read from the network data, and thanks to this reliable digital twin of the network, you can close the loop and implement a seamless and autonomous restoration from failures, soft failures at least, or rerouting of some traffic. So let me conclude this talk. So initially, in 2017, we started with the idea of GMPY to be only a planning tool with all the design capabilities that is still extensively used, for instance, by Orange, and will be prosecuting in this direction the development of the GMPY. But and the GMPY scientific core has shown a remarkable accuracy in performance prediction across multi-vendor scenario, multiple transmission technique. The ongoing update of the GMPY core aims to enhance features by achieving ultra-low computing times also on modern scenario, multi-band, flash grid, flash rate, different receiver, and so on. And so we are moving toward putting on the side of the use of GMPY as a multi-vendor, vendor-agnostic planning tool, also to use as a vendor-neutral digital twin with the digital model within the digital twin. The introduction of an interface expands GMPY utility, enabling open optical transport automation, in addition to vendor-neutral design and planning. And last but not least, of course, artificial intelligence in general, machine learning specifically, can be effectively used to amend the GMPY accuracy and capabilities. Thank you for your kind attention. The floor is yours.
Thank you. Okay, so let's go back to the optical line. So all of you know what is optical transmission. So you have the electrical to optical conversion, the transponders. You have the amplifiers to compensate for the loss. And you have the fiber. And eventually you have some nodes to steer the signals. And all of these need to be coordinated very carefully, but all of this need to be designed also very carefully. So now if we look at the design, all what Vittorio explained, this is physics. And the physics is meant to be the same for everybody. But what happens in reality is that for planning tools, all the planning tools are different and are not compatible. That means that they are really specific to the vendors, specific to what the suppliers has as equipment, specific to their engineering rules with proprietary models, and most of all, they do not support scenario across vendor. And GMPY instead support this kind of scenario. It's an open source and is capable to support these multi-vendor scenarios. So let's see what we can do with GMPY. So you can do a lot of things. Because GMPY, you have the optical modeling, so you can do a simulation of propagation. You can do optical design, and with these two basic functions, you can do planning. You can do what-if tools. So, for example, you want to change an amplifier in your design and check, but what if I change to this new type of amplifier? Does it do? You can introduce a new type of transceiver and check, okay, what would it do? You can simulate that. You can plug it onto your controller, on northbound of your controller, and check feasibility online. And this is a topic of today, you can use it on your procurement process within request for proposal or request for quotation. And in this scenario, what you would like to do is to evaluate the pricing of use cases. So you want to consolidate the price that you receive from your bidders and have the same technical basis. So what you provide is a use case, and you want to benchmark a particular item, for example, the capability to support large traffic or the capability to support very demanding infrastructure. And then you ask for this scenario, and then you receive a response, and then you have a lot of difficulties to compare them because, as I told you, all these planning tools are very different. So you have responses which are very hard to compare, and most of all, you don't know exactly what has been designed. And if you need to really go into deep to check that all the constraints you wanted to have are really taken by the answer, then it takes you a lot of time. So in this context, we found that using GNPY is very powerful, and it's, what we used in this context is templates that come with GNPY. So with the templates, we were able to provide our bidders with a single way to describe the use cases, and we were able to analyze their response in a similarly using GNPY. So the advantage of this process is that there is no more interpretation in terms of the scenario. There is no blank in the scenario that could be interpreted in one way or in another way by the bidders. And also, it is the work for work for operators, because with a standardized format with answer, it's really easy to automate the analysis. So what are the steps to do this kind of use case? So first you need to provide the bidders with the use case, and the way we did it, because we did this in Orange, we used it in RFP. We defined the scenario in such a way with GNPY that we could also do the design so that there is no blank. So the scenario is fully detailed, and you can use it as it is. And we prepared the templates that we provided to bidders with a companion doc to explain how to use the templates. And then there was the feedback analysis and the loop with vendors and bidders to analyze their response. Typically, you receive the answers, and then you check, are all the constraints well kept? And you see, okay, no, this constraint is not applied, so go back to the supplier and ask a correction, and then do that until you have the scenario that is well taking into account all the constraints. And then once you have that, you can analyze if the scenario is feasible or not with GNPY, for example. And if you find that the scenario is feasible, okay, and if you find that the scenario is not okay because of GNPY, then there is a start of discussion with the bidder to understand where the difference comes from. So with this is a typical assessment grid where we check different things, and what we found is that in the first round, all the answers failed at least one of the items. So we need a lot of loops to get into an alignment of the technical basis. It results in an increase in the pricing of the use cases, but in the end, what we have is a really aligned, technically aligned, and we can do fair comparison between all the offers. We expect that the loop will be faster the next time, because now you are used to the method, so you know how to answer to this kind of method, and we expect also that this could be also this could have a lot more impact if more operators get into this process. we also found during this process that open source is very interesting in this case because the assessment rules, they are fully transparent. I mean, it's an open source. All the bidders can look at it and understand what is going on. And also because GenPY has a very good accuracy, as Vittorio said. So it's a really good base of discussion with the suppliers. And then we also found that automation is key to facilitate the RFP analysis. So right now it's not automatic, semi-automatic, so you need several clicks to have the answer. But we expect to improve that with one-click operation. And also what is interesting is that GenPY has a lot of expertise inside it, but it's really easy to use. So you can have a lot of users a lot of assessors for the analysis, and this really eases the process of RFP. So as a takeaway, I would like you to keep in mind that when you think of GenPY for operators, it means economy, it means saving, because you can have a really good, strong base of discussion with suppliers and to have the technical solution that is with a good price. That is also a reference for the industry. It's been driving the introduction of optical impairment in the standards in the ITF and in TAPI. That is instrumental for the automation with multi-vendor. And for us, it's a unique means to gain autonomy on our network design. And with this presentation, I also wanted to show you that it's also a powerful tool for RFPs. Thank you.
Thank you, Esther. Thank you, Vittorio. Okay, so we're moving to the last session now, and we're running a few minutes late, and we may overrun by about 10 minutes. I really hope that you can stay with us for what will be an interesting panel session. We're going to move on to the topic of IP over DWDM. By way of a bit of an introduction while the stage is moved around. New transport architectures based on IP over DWDM are of increasing interest to network operators. Potential to reduce CapEx in their next round of network deployments. The latest generation of longer reach, multi-rate, pluggable solutions based on QSFP-DD form factors with the longer reach ZR+ Bright capabilities giving increased range means that solutions really are being positioned as an alternative to traditional transponder, muxponder equipment within the metro. If we think about how the first generation of ZR plus digital coherent pluggables has been integrated and the ecosystem has evolved, it's really quite mature now, and we can probably argue we have a plug-and-play ecosystem. Looking out further ahead, longer reach solutions, including ROADMs, it means the requirement for a management and control infrastructure becomes increasingly important for IP over DWDM. And in that context, the coordination between the IP and the optical layers is absolutely critical. So in that context, I would like to invite our panelists, Jeff, Nigel, Matthias, Abhijit and Oscar, to come to the stage to give us their personal views on how the state of the art is evolving and also their organizational perspectives on the new paradigm. Welcome, everybody. Welcome back to some of you, and welcome to the stage for the first time. Jeff, I'd like to push the first question to you, if that's possible, please. What are the target scenarios for IP over DWDM deployment by operators, and what does that mean in terms of the management functions that we expect that are going to be needed?
Yeah. Thank you. Hello, everybody. We had a lot of discussions also in the Chip Mantra group on the typical scenarios, and for an operator, as you mentioned in your introduction, the low power ZR with a shorter reach has several applications. For example, for point-to-point high-capacity links in the metro area. So, for example, between a core router and an internet border router. But before entering in the scenario, I wanted to mention that, as you correctly mentioned, I had questions from colleagues when we were speaking in standardization, but operators, you will just remove all the transponders and put ZR plus everywhere. And I was saying, no, of course not. This is an alternative, as you said. Of course, it has cost benefits, power consumption benefits, a simplicity of deployment benefits, but then it's not fitting all the scenarios that we have for all what Vittorio and Esther was explaining, due to the optical characteristics and so on, it cannot fit everything. So one scenario is clear, point-to-point dedicated links. Here, you don't even need to have the optical management and control, so it's really dedicated infrastructure. But then there is another scenario that covers, I think, a lot of interesting links for metro regional in the core network, for example. And here you can imagine simple scenarios where you have only 2 ROADMs, and in between you have I don't know, 4, 5 line amplifiers, so in different sites. And in that case, I think you can target scenarios between 100 kilometers up to 400, 500 kilometers. And I think these are the main one. And here, the benefit of the high power ZR Plus is that with the 0+ dBm output power, it's a very similar characteristic also from the optical side with the native transponders. And so we can use the same type of add-drop filters that we have in the ROADMs. So if it is a CF ROADM, a colorless flex grid, sorry for the abbreviation, colorless flex grid modem, or if you have a CDC, so colorless, directionless, contentionless flex grid modem, then you can use the same type of filter that you are using with your native transponder. So it's an attractive scenario for operators.
Fantastic, thank you. I mean, attractive scenario for operators, but for optical vendors who are used to delivering proprietary integrated hardware and software solutions, there's a requirement to adapt their strategies for the sort of open software-centric world of IP over DWDM. Nigel, how are they coping with that?
So maybe I'll just start with, I'm very old, so I started in optics in 1981, and our first system was called proprietary optical line system. Our second was called standard optical line system. I think what happens is that when you're an innovative front end, you have to go proprietary. There's no other option. As I said earlier, it's a blend of proprietary and standard. Ciena's an optical IP, Ethernet, etc. vendor as well, so we're familiar with the blend, and I think it's getting the right bits, getting standardization at the right times is the critical thing, drawing component boundaries in the right place, and making sure that then we all progress towards that standard interface. And I think as you said, software is super important, but it's always been important in optics. It's just that we tended again to be proprietary, because hopefully in the presentation I did at the beginning, I demonstrated that standardization is front and center to us, and that consistency that we're getting driven from the operators is really important as well to help us down that path.
Fantastic. Matthias, I wonder if you have a perspective on that issue.
Yeah, absolutely. So first, I mean, speaking from the vendor side and also from the optical side, I fully concur with what Jeff said about let's say a little bit stopping the hype about the 400 ZR plus completely obliterating and disappearing the transponders. We see actually a sort of hybrid scenario, depending on all the topics that Jeff said. But from a vendor point of view, I mean, Nokia, it's actually, I mean, it plays a double role because it's both an optical and an IP player. And the way we see it is that, so IP and optical has always been, there has always been a requirement for correlation and coordination. Now that has taken another step forward. We think that from a vendor point of view, there is a need to align the automation strategies for both IP and opticals in order to successfully manage the lifecycle of the services. And that means, in practical terms, to share the operational procedures that are today applied in both IP networks and optical networks. An example of this is, for example, the planning. There is, as Esther and Vittorio mentioned, planning in optical has always been there, not so much on the IP. Now, if you want to deploy 400 ZR and 400 ZR plus coherent pluggables, you need to do planning to test the feasibility of those services. And IP needs to understand that this is a step needed in order to accomplish the deployment. Not only that, but also the power management, the performance management. You want to keep your proper SLAs, and that requires a strict, let's say, coordination between IP and the optical layer. And that can only happen with a software open and standard software layer.
Fantastic, thank you. Abhijit, I talked about the need for optical vendors maybe to adjust their approach. How do IP vendors go about integrating IP over DWDM within their product and service solutions, given the underlying complexity of optical?
Yeah, it's a great question. So we're riding on top of the standards that have been defined already. So TAPI and CMIS have been core fundamental functionalities. So we adopted those to be able to have a multi-vendor situation from a pluggable optics perspective. But that's just the start, as was mentioned earlier. From there, now we can start innovating on how does that now interact with IP SLAs or service level SLAs, even when you're doing things like segment routing, right? So that's the next level of innovation that can happen through software in this case.
Okay, fantastic. Oscar, I'm going to come to you next. Talking about the challenges of integrating ZR plus coherent modules into routers and the technical challenges, what are the obstacles in getting to a sort of a plug-and-play ecosystem?
Well, we have observed now that the simplest scenario of the data center interconnection for the CR has reached a very high level of maturity, and there you can have plug-and-play. However, going to the CR Plus, we are still one step behind. Okay, I'm not saying we are not there, but almost there. We have just seen last week at ECOC that the first interoperability between the hosts and the routers and the pluggables for OpenCTR Plus were achieved. Okay, also with engineering versions. So we see that this is slightly moving on. So, but this first barrier that was the CMIS that we require advanced new functionalities for going with the 0 dBm for the scenarios that we require, and we see that within maybe few months we'll be there, but we are still a little bit lacking behind. And the second thing we see the challenge there is that IP routers now need to have a little bit of optical mentality. Okay, so that means you need to implement the interfaces, not only all the IP interfaces that are perfectly good enough, but also they need to implement all the optical telemetry, all the capabilities that you have in a regular transceiver, but also to be able to monitor it. Because remember that from operator side, we need especially the end-to-end visibility, starting from router to router, crossing through the optical network. So we need also all these capabilities to be integrated in the routers, and we still see that they are, let's say, in the early stages. Okay, so I think they need to mature a little bit these capabilities in the routers.
Okay, fantastic, thank you. Nigel, I'd already talked about the need for optical vendors to evolve. But if we think about locking concerns, solutions have traditionally been proprietary, locking customers in. How do IP and optical vendors deal with the locking concerns of operators when it comes to ZR and ZR plus pluggables? And how do the standards processes need to evolve to enable vendors to innovate but still give operators the flexibility to be able to choose between suppliers?
So I think the lock-in is also, there's the reverse side of lock-out. So as a vendor, you may be locked out of something, so it's not just an operator problem, it's a general problem. The critical thing, I think, is, as I was saying earlier again as well, defining the boundaries right on the components, defining the interfaces early on, not allowing monoliths to occur where there's violations of the standards and so on. So enforcing those points very strongly. And again, that's, I think, where the operators come into play again, because the strong, you will abide by this boundary is critical. And I think that if you take a sort of an enlightened view, if you're not locking in, you're also not being locked out. So it lets the industry move forward. The interfaces have to be defined, though, with the opportunity to enable innovations. That's another critical thing. You can't afford to have, and I know some of the earlier standards used to be like this, here's the thing you must apply to abide by precisely, you're not allowed to have any additional attributes, no augmentations, nothing. And that then means you can't innovate. So you go, I'm not doing that. Whereas if you're now allowed enough wiggle room, and that we need to learn better, because it's not just simply augmenting with proprietary properties, because then you get away with just having a proprietary interface again. It's having the right enablement for that. And you've also got to recognize that often these areas of innovation are IPR, or they may even be sort of almost secret, and you've got to find some way of enabling those properties to propagate to where they need to without being interfered with, inspected, etc. So there's even areas like that where I know we have some issues with some of the parameters. We don't want to expose these because you can then see what we're doing. So you've got to enable that carefully as well. So there's some techniques I don't think we've got yet that we need to understand in the standards. Maybe some encryption. So maybe it's a Yang model with an encrypted bit in it you can't actually see, etc. So things like that we need to think about carefully. But I think it does come down to drawing the boundaries right and drawing them right in the right way.
And a delicate balancing act by the sounds of it. So thinking about standardization, coming back to you, Jeff, what are the main challenges you see in terms of the standardization process and creating an open SDN management and control architecture for IP over DWDM?
Yes, first, before addressing the challenges and the possible gaps that I see, I think it's important to recognize all the work that was done in the past years in the standardization bodies, in OpenConfig, in TAP, in ONF, in IETF, for all this partial optical disaggregation and disaggregation in general. And I really encourage the standard bodies to collaborate more. We have a good example with IETF and ONF, TAPI, for the optical impairments, where there was a good collaboration and not reinvent the wheel again and again in the different standard bodies. I realized after answering the first question that I didn't really mention which are the management functions that are more important, the most important for the operators. And I think the most important is for the second use case that I was telling you, when you are using the existing optical network, then you need at least to have the end-to-end visibility of the topology, of the PMs, of the alarms, and the correlation also between, for the alarms. So this is really the key points, and I'm sorry because I forgot to answer this part of the question. And for the standardization, this is important. Let's separate southbound from the northbound. So on the southbound, for the ZR+, we see that a lot of things are already there, because in I am in Tip-Must Optical, and in Tip-Must Optical, during the last 2 years, I think we defined a lot of requirements for managing third-party optical terminal. And so multi-vendor scenarios as well, with an OLS from one vendor and the open terminal from a third-party vendors. And here we define all the main functions that we needed as operators. And most of what we need is there already, and you could see it in the Anders presentation that we are testing already a third-party terminal with these open config data models. So for the discovery, the capabilities, for the PMs with telemetry, for the alarms. Okay, alarms are not standardized, but you have a standardized framework for the alarms. And we can think that in the future, we will be even able to have standardized alarms, but I don't think it is critical. So this is for the southbound, and for the southbound interface, we really believe that the pluggable is not different from the third-party open terminal. So finally, these open config data models should work as well and should be supported by the vendors. And on the northbound, we see some more, perhaps some more points to be put in place, but these are not very difficult points, because on the optical side, I think the TAPI has evolved a lot, and with 2.4.1, 2.5.0, now there is really a good coverage of the scenarios we need. But on the IP side, I still think that there are things to be delivered for performance monitoring, and so for mapping what we have in southbound to a northbound, and be able to have a multi-layer view in the operators when you deploy new IP services, to have the IP link, but also the ZR Plus connection that is below this IP link. So, yeah.
Fantastic, thank you, Jeff, and thank you for coming back to the earlier question too. Matthias, thinking about SDN controllers, how do, in your view, competing interests impact on the standardization and the interoperability processes in terms of creating that IP over DWDM ecosystem?
Yeah, that's a good question. It's a valid question. And the way we see it is that so competing interest in standardization has always been assumed. It's life, basically. And this is not something that applies only to IP over DWDM. And there are many success stories around, let's say, driving standardization with a common goal. I think one of them is, that was mentioned before, is TAPI. Actually, two vendors which are sharing this panel, driving a standard, putting aside, let's say, their company interests to achieve a common goal. This is a success story. But back to IP over DWDM, I think here, I mean, there is a lot of promise around all the benefits that it can lead to, from diversified supply chain to reduction in CapEx. This, like Nigel was saying at the beginning of his presentation, this comes with a cost, and the cost is the integration, basically, and the operational complexity that it carries. This is something that today, as Oscar was saying, it's a reality, but it only, let's say, drives the need to double down on the work that ONF, OIF, and TIP Mantra especially are doing, which are basically defining clear targets, clear architectures, selecting the right interfaces. As Oscar was saying, I mean, it's not about creating another standard organization. It's about seeing what the industry already has and putting it all together with the operators' need behind. So they are speaking in a sort of one voice. And we were mentioning this topic with Nigel, let's say, from a vendor's point of view. It makes our life easier. That's a fact. I mean, it always helps to know that there is a sort of beacon, there is a one, let's say, common goal that all operators, all customers share, and do not need to basically cater for each and every different specification. And that's something that we encourage TIP to continue doing, and also to have more operators and more vendors to participate, because we think that it's the right approach.
Can I just say, I fully agree with that. It's been very helpful.
Fantastic, thank you. I mean, the interesting thing I pick out there is the common voice. Abhijit, how relevant is that? In the IP world, there must be challenges for open control and management of IP over DWDM in multi-vendor implementations? You know, can IP and optical management systems, you know, coexist happily in that scenario?
Yeah, so I think first I want to celebrate some of the things that folks on this stage have done in terms of standardization, right? So let's start looking at Cassini, right? So 100 gig, 200 gig, using the TAPI interface, using MUST and the OIF standards, we've already been deployed, right? That's already been deployed. Then if we start looking at 400 gig ZR Plus with things like segment routing, again, with CMIS standards, that's been deployed. Now bringing both of those systems together, because as they mentioned that need to coexist, can't rip and replace everything, using a standard variable array, that can be achieved. And interestingly, with the new aggregation platforms, that can be a client interface up into the Cassini, right? So you can have that coexist as well. So then what remains, right? So the next level is, as was mentioned earlier on this stage, is how do we take the information that we are now collecting from the IP side and we match it to the information collecting from the optical side? Because the IP is thinking about services in terms of eVPN, L2 VPN, L3 VPN, and the optical is looking at it in terms of I have 4 lambdas going over this direction, 4 different lambdas going on the other direction. What happens if one of those lambdas starts misbehaving? Do I bring the service down? Do I switch over the service? Do I trigger the segment routing to fail over? So that's the level of information that next control has to start looking at. On the management side, some of the very exciting things that are happening is the FlexGrid MSA, and that's being closely followed. I'm hoping that that will come into the forums that we are talking about and drive that forward as well.
Fantastic. Thank you, Abhijit. Okay, perhaps a last question to wrap us up, Oscar, if that's okay. What are the next steps being considered in TIP Mantra in the context of sort of managing IP over DWDM systems?
So we want to follow the success story of MUST Optical. So now the very first thing that we are going to do is to compile the use cases that were described before by Jeff, describing those so they can be read and they can be implemented by the suppliers. And there we are going to start looking at how to use the existing models. So we think that maybe 90% of the work that was done for the open terminals can be reused here. Okay, we know that we are not in an open terminal. This is a router, okay, and so we need to do some adjustments, some refinements, and there we want to say, hey, these are the use cases that we want to do. These are the interfaces that needs to be implemented. Here they are, and most of it will come later. We expect it will, based from that, just an update of the specification in MUST Optical to be able to be used in routers. And in addition to this part of really documenting to guide the suppliers of how to implement in a unified way, not battling by itself, also perform the POC with the different suppliers. So we are ready to start now with smaller integrations, or with, let's say, not all the solutions together, and our target is next year to go with the full integrated solution with the different actors. Okay, so these 2 steps. First, we work with this documentation of the use cases and how to use it, and then next year we do the full POC. And now I think everybody's waiting for something that starts with B.
Fantastic, thank you. Well, look, I'd like to thank the panelists for an interesting discussion. I'd like to thank all the speakers that gave us the presentations earlier, and I'd like to thank you all for sitting through to the end, and as Oscar suggested, maybe time for a drink. Thank you very much.